All right, I'm told that the camera is on. So, thank you all for coming. My name is Granicz. I wanted to thank the sponsors who sponsored this awesome conference. So please take a look. So today I'm going to talk about functional and reactive web abstractions for .NET. How many of you here are functional developers? All right, I see a few hands. Okay. So this is going to be somewhat new then. For this presentation, I'm going to be using a functional / reactive framework for F#. It's also now available for C#. It's called Web Sharper. If you had attended my talk last year, you may have remembered what I was talking about there. I have a few slides to refresh your memory, and I'll talk about a few recent development that we have done with Web Sharper. But just as a sort of like an intro, I want to give you a few numbers. So Web Sharper is a web development framework, like I said. We had basically been working on that for probably about 7, almost 8 years now. And in the last few years, there have been a lot of changes in Web Sharper. And one of the changes that I think very positively affected the whole community is that we open sourced the entire project and we put it on Apache. And with that, a lot of new contributors, a lot of people came to the community, lots of companies, lots of people started using it. So by now we have over 100,000 downloads just from our website. We have no idea how many people are using it next to those downloads from GitHub and the other sources where you can get it. But basically, it now grew into an entire ecosystem of web development libraries next to the core compiler that compiles F# to JavaScript. You can see the URLs in the bottom. There's websharper.com, and there's also a site called try.websharper.com. This is a site where you can go online and test various snippets. I urge you, I will be demoing some of these snippets in this talk, so you will get a feeling for it. As I said, Web Sharper is an open source project. You can go and get it from GitHub. There are many forks. There are different companies customizing it for different purposes. As in its current form, you can use it for web-based mobile development, which is something that we as a company are heavily involved in. But for most of the other purposes, it's for web development. You can basically get Web Sharper in different ways. It's integrated into Atom, for example. We have a plugin for Atom, but for the main part, this is a .NET tooling in Visual Studio and Xamarin Studio. You can, of course, compile these applications from the command line. You can use different other command line tools like Yeoman to install and run Web Sharper applications. And we also have an online ID, cloudsharper.com, and there's another upcoming online environment that I'm going to be demoing to you at the end of the talk. So these are the different ways of you being able to run and experiment with Web Sharper. Let's just have a walkthrough on what kind of applications you can develop in Web Sharper. So primarily, it's a client-server application development framework, which means you write your entire code base in F# and now in C#. So you write the client side and the server side in the same language, and with Web Sharper 4, you can also mix C# and F# in the different parts of your application. But primarily, it's full-stack web development in any one of those .NET languages. Next to the client-server applications, the other primary type of applications that are targeted are single-page applications, SPAs, which you can then package up for mobile consumption. You can use Cordova, for example, to get these web applications into different app stores, iOS, and Android, and so on. And the third type of applications are HTML applications. These are purely client-side applications consisting of nothing but HTML and JavaScript. which is distilled from your F# or C# code base by the compiler. So the whole picture looks something like this. So you have, let's say, an F# module, an F# file with 2 different modules inside. You can group the server-side and the client-side functionality separately, like I did in this slide. You don't have to. So WebSharper is based on making certain attributes and annotations in different parts of your code base, and then the compiler is smart enough to figure out what kind of code to generate and how. So in this case, we have a client-side code, which is annotated. There's a function there for my client function. It's attributed to be JavaScript, so the compiler will output some JavaScript code, and then somewhere in the execution of the JavaScript function, there will be a call back to the server, which, as you can see, is annotated as RPC. So this way, the server tier and the client tier can interact seamlessly, and you as a developer, you don't have to worry about the communication details. Everything just becomes a plain F# function call to another F# function. In my talk last year, I have detailed that story, and I also gave some feedback and some details on various other components in the WebSharper architecture, including like resource management, type-safe URLs, and a bunch of other things. I'm not going to do that this year. You can go back and revisit that video. I just want to talk about today about the different functional programming-inspired web abstractions that we have in the framework. And these include sitelets. So I'm going to be spending a few slides on how you can represent web applications, microservices, different server-side abstractions in the F# or C# type system. So I always say F#, but every time I mean F#, I also mean C#, because now you can develop and use all of these abstractions in C# as well. But in this talk, I'll primarily concentrate on F#. So sitelets would be server-side abstractions. The remaining items here, pagelets and UINext, formlets, flowlets, and piglets, those are client-side abstractions to model different things. So pagelets model dynamic markup. This is HTML and certain behavior, like event handlers and any kind of functionality that you implement in the client side. We have built on the top of pagelets another layer which establishes reactive DOM manipulations and dynamic data flow, basically allowing you to write reactive applications on the client side. And then we have formlets and flowlets. They are basically an abstraction for representing user forms in your web applications or web pages. Flowlets also give you sequences of those forms. And then piglets basically are the same as formlets, except they have an additional capability of being able to customize what kind of markup you output for your declarative user interfaces. So if I wanted to tell you in one sentence what you should be paying attention to, that would be the number 3 and number 6 combined. So having reactive piglets, which we just so eloquently called WebSharper forms. So these are the abstractions that give you the most productivity. They give you a reactive, declarative style user interface specification sublanguage inside F# and C#, and you can go from there. And basically, looking back just on our own enterprise application development projects, just about every single one of them uses reactive piglets. So that would be something to look up to, or look up in the documentation. And if you're interested in this, that would be the first thing to try. However, I want to walk through the rest of the abstractions because they kind of are a roadmap to arrive at piglets. And now, let me talk about sitelets a little bit. So for example, let's say you want to build some microservices for your user interfaces to consume. This would be the smallest microservice. It does nothing but response hello world. And it does so by outputting some string to the request or of this service. As you can see here, there's very minimal ceremony. We opened a couple of WebSharper namespaces. We have a website attribute. That's F# syntax for attributes. In C# you would omit the angular brackets. And then we simply defined a website called main, which is a text-based application, and taking an anonymous function that from any of the context or from the context for any request simply returns hello world. So very simple. If you want to scale that up and say return, I don't know, HTML responses, then you would add the following code. First of all, you would open a couple more namespaces and modules, and instead of returning hello world as a text, you can now start to use the HTML combinators contained in UINext.html, and you can say h1, and then this way, content.page, abstracting away the details of constructing a whole HTML response. You can plug into its body just an h1 tag with that hello world text. So this now would return hello world, but this would be an entire new and full HTML document. All right, so sitelets definitely make your life easier as a web developer who is building microservices, but oftentimes you of course need to pass certain pieces of data as arguments to your microservice. So for example, this is how you would pass, let's say, just a very simple integer to your microservice. So in this case, we simply define an endpoint type, and we eloquently say that it's an integer, and then we also have a website just like before, but instead of a textual or a single page application, we have something called sitelet.infer. This is like a magic function that is basically able, from its own continuation function, or the function argument that it gets, infer from the endpoints that we analyze the different kinds of requests and how they can be matched, etc. So this basically says, I have an endpoint of type int, which I match as I, and then whatever I comes in, I square it and I return it as text. So in this service, let's say exposed at localhost, if you do localhost / let's say 100, then you get 10,000 back as a response, as a text response. So this is how you can scale from taking no arguments to having some kind of an argument, but this is still very simple. So you can go up and say, I want to request something, but then the response should be constructed not as a simple text, but maybe as JSON, which is very typical. Or you want to return files, error codes, or something else. Those we all have different wrappers around. So if you look at, for example, the second one, the JSON, we have, let's say, in our type system, a person, and here's an instance of it with John Smith being 30 years old. All I have to do is basically say content.json, and this actually constructs a JSON representation of any .NET or F# value in the type system. And this way we can feed it back in our handler. So if you modify the code, instead of returning content.text, I can return content.json of that person. So this way I can take and I can return structured results and responses. So now what we need to do from here is scale up. So we have microservices of a single endpoint, which, as we have seen, can also be argumented, and we have used integer endpoints. But you can make the integer endpoint something else. You can make it any of those default base cases, so you can have floats and strings and some other base types. And you can also scale up to aggregate data structures. You can have tuples, records, options, and then lists and arrays. So passing a list of, I don't know, arrays of tuples, which is a fairly complex aggregate data structure, you can simply just define it as an endpoint, and then your pattern matching will return that to you when you are actually processing the request. So hopefully you can see that in just about a few lines of code, we can write a microservice that takes structured data and returns whatever response that we deem is necessary. However, it doesn't stop there. So remember, the idea here is that sitelets and all the other abstractions I'm going to be talking about today are meant to bring more and more capabilities into the type system. The reason why we're doing that is because in the type system, certain things become easier to manage, and also because we have a compiler, the compiler can point out different inconsistencies in the code base. In fact, what we have found is that using these abstractions, you can catch, and not only just catch, but eliminate entirely large classes of errors that otherwise would occur in traditional mainstream web development. So there are some modifiers attached here I'm going to be showing you a couple without too much detail. So one of the modifiers you can basically attribute onto an endpoint is the endpoint modifier. So in this case, we have some structure type for our endpoints, and in this case, it's a single case discriminated union. Don't be scared of the syntax. This is F# for discriminated unions. And as a C# developer, you will probably be seeing this in the upcoming releases of C#. Discriminated unions are basically multiple shapes bundled into a union type. So here we only have one shape. It's called about. And then preceding the about shape, there's this endpoint attribute, which we say basically about as the endpoint is accessible if somebody is requesting it as a get request @/about. So basically this is bundling in like a router into the type definition of our endpoints. So far so good? So as you can imagine, if I had a multiple entry point service, in other words, a service that responds to multiple different kinds of requests, all I would need to do is list more of these lines. And of course, specify carefully the endpoints where they're available. Here's another modifier. It's called query. And query basically specifies that whatever parameter is passed should be passed as a query argument. So if I have a request like /doc/1234 and then !version1, using the above endpoint, where you can see that there's a query parameter for version, which on the discriminated union case is matched to be an integer option, so it's either there or not, I can match that as either some1 or just simply a non-value, and then the 1234 is basically matched always as an int. And the way version is matched is as a query argument. So if it follows using the question mark syntax, then we match it, and if it's not there, we don't match it because it's an option. So basically, there's a lot of flexibility that you can encode just in the declaration of this type, and you don't have to worry about how you get this request matching, because that's taken care of by the Sitelet handler in your application. So there are more and more complicated cases. I don't really want to go into the details because I think we will get lost. But here's another one that says some of the arguments to the endpoint should be passed as JSON. So here we say that order, which actually should be data instead, not order. That's a typo. That should come as JSON. So if we post, in this example, to /create a JSON representation of a book, then the Sitelet handler will recognize it automatically. And you don't need to do anything else. So basically, in just a few minutes, you can write complex real-life microservices and expose them to the world and your own applications. So this is what sitelets are supposed to do. There's a couple more here that I don't want to talk about. Passing data in and out as form data, for example. That's another case, but I think we can ignore that for now. So this is basically the server-side functionality. Let's talk about client-side. So let's say I'm building a web application that has, some fancy pages, and in the pages there are some requests on demand going into the server. So how would I represent what I see? So one way, which typically ends up being the most pragmatic way, is using templates. So what you see on the page basically comes from some kind of a template, which is instantiated on the server side, filled using some placeholders and some content, and then sent back to the client. So to represent this, in Web Sharper you can use something called a type provider, which if you attended our training or workshop on F# yesterday, then you should know what type providers are. Basically, they are a mechanism to generate code on the fly within your integrated development environment. So the following code basically says, we have a type space called main template, which basically will be generated from the main.html file using the templating.template type provider. So this type provider looks at this HTML file, it finds some placeholders and some special annotations, and then generates some code for us. And it happens to generate code in such a manner that I can then instantiate this template in the middle of this slide. It says main template.doc, and then title equals something, menu bar equals something, body equals something. That is the instantiation. That's because those placeholders are assumingly in that HTML file. So this way, I as a developer, I can say, oh, my friend designer, please design me a nice page. I will put some placeholders in it, and then I can consume that template and immediately recover the placeholders inside the template, and I can then put some content and serve the template back with the placeholders field. So if I had this, here's for example a template. These are the typical attributes and certain data attributes that you annotate certain DOM nodes. So we have data replace, we have simple variables, we have data whole, we have some special ones like meta, styles, and scripts. Those you should keep in the template, because Web Sharper will actually generate dynamic content into those placeholders. We also have an additional layer into these templates where certain types of variables can represent reactive content. It's probably easier to see this in an example, so I'll get to that in a second. But basically, you're able to say you have reactive variables, you have views of those reactive variables, you have maybe inside nested templates within those templates, event handlers and attributes that are reactive, etc. So these additional dynamic elements are available for templating as well. So if I had, okay, let me get back to this first. So when you are eventually in your code base get to the point where you can freely figure out what kind of content you want to instantiate your templates, you will be writing HTML code in F# or in C#. So here's an example. So UI Next exposes a layer called UI Next.html, which also comes in a server-side and a client-side flavor. So the client-side flavor, for example, containing the reactive stuff, containing event handlers, and certain client-side functionality, whereas the server-side has other functionalities, such as embedding client-side functionality, etc. But basically, the bottom line is that every time you see something like div, hr, or div attr, or h4 attr, these are basically HTML constructors. They construct HTML programmatically. So in this case, you can probably kind of read this. In the middle, we have a div, and inside the div, we have an input text box. And then we have a button next to the text box, which if you click, will asynchronously go back to the server with the content of the text box, and it will basically get some value back from the server, and it will embed it inside another placeholder called output, which is underneath in this third line, fourth line. Here's output embedded into this HTML structure. So we get HTML, and inside the HTML, I can already describe what kind of functionality I want to execute. And in this case, this is a client-server call. I can embed all of that into this simple function here. So event handling, basically, in this case, I emphasized it, that on whatever node we are talking about, you simply add an attribute. And in this case, you can do that with the on module, which has a bunch of different kinds of events. In this case, you can say on.click, which takes the event handler itself in F#, and you can embed this into your markup. This is F# code. This is not HTML, but it's generating HTML with event handling, dynamic functionality, server-side callbacks, etc. Here is the function that is being called in that example. So we just defined a server module. I can even put this into the same file. And all I had to do is put the RPC attribute on that function. And basically what it does, it receives an input. It defines an inner function called R, which takes a string and reverses it. It's doing it in some funky manner, and then asynchronously returns the input piped into that function R. In other words, we get a string and reverse it and return it asynchronously. All right? So if I had, let's say, a 2-page web application where I want to expose this functionality, and I have the templating mechanism that I showed you, I could define 2 functions, homepage and about page, which uses the templating engine and puts some stuff in the template. In this case, it just instantiates the body placeholder in the template. So in the first one, we say hi to the server, and then using this funky syntax, we embed some client-side functionality into that template. And client and those funky 2 characters is the means of doing that. If you are used to F# programming, you may have seen that syntax. It's called quotations. Basically, they allow you to specify certain expressions not as the value of those expressions, but as the AST, the abstract syntax tree, F# AST of those expressions, which then can be interpreted in any way. So this here, WebSharper will look at that code and it will generate certain calls and generate some code and make sure that everything is okay. And in this case, client.main, remember, is this function that we had. For example, this, which is client-side HTML with some dynamic behavior. So we embed it onto the server-side markup, and then simply, so clearly we are talking about a website here that has 2 endpoints, home and about, and then we construct a sitelet, and we say, if you request the home page, then we serve you the home page. If you request the about page, we serve you the about page. And keep in mind that those were defined as such. So we're going to have on the home page some client-side functionality which contacts the server and reverses something. And in the about page, we just have some static text that says, I'm the about page, and do whatever you want. So basically, this would be the screenshot. I have the application also in Visual Studio if anybody's interested. It's pretty much the same kind of code. I can show you that after the talk. All right, so now we have a way, and we have shown on this very small example, how you can expose server-side functionality and how you can build some user interface on the top of it. So now the question is, how far can we take specifying and writing the users, the client-side user forms and the user interface? And before we do that, I just want to have this one slide here, that if you take the sitelet modifiers and you take them to a more practical end, then, for example, you might have a REST service which provides get, post, and put and delete requests for storing, let's say, people. So here I'm making an imaginary data structure person, which could have, I don't know, first name, last name, age, whatever. And this would be the interface. This would be the endpoint type definition for the entire REST service, which of course you would need to map something like this, and then say, if you had matched the delete command, do something. If you did match the other one, do something else. So it would be 4 additional cases here. And you're finished with your REST service, probably under 25 lines. All right. So now let's talk about the user interfaces and building client-side functionality. So we saw already the HTML templates. We saw some reactive placeholders. I could probably demo. In fact, I think it's probably a good idea to show Try WebSharper at this point. So Try WebSharper is this website where you can basically type some F# code. It gives you code completion. It gives you the ability to I don't think you can see that too well, can you? So let's say we have something like this. So if you walk around, you can change this code, and then you can click on the run button on the top, and it will basically refresh the right-hand side. It compiles that F# code or C# code into JavaScript and HTML, and then you can basically test your application on the right-hand side. So before I even test here, let's just move on to here. And let me show you the two-way data binding. Let's get that out of the way. So probably a lot of you here have done reactive web development already. So one of the main ideas in reactive web development is two-way binding. Two-way binding basically is a very simple scheme. On one hand, I have some kind of a user interface artifact, like that text box on the top. Imagine that as an HTML text box. And then on the other side, we have some code which can programmatically manipulate the content of that input control. But instead of directly writing into the input control, what we do is we establish a binding in between the user interface and the program. And we establish that binding using a model. So we have a client-side model. And in this case, let's assume we have a very primitive model. We have a simple, single reactive variable. This is my model. That reactive variable is bound to the input control, and it can programmatically be changed. And as soon as you update the value programmatically of the reactive variable, it will update the user interface control. That's the very simple idea. So for example, we have two-way data binding, and we have reactive programming, other functionalities that you will typically need. We had encapsulated all of that into what we call UI Next. And UI Next is one of the libraries available for WebSharper. So I can do something like this. I open UI Next as a namespace. I create a reactive variable. I assign a value to it already. I create an input control binding. This myvar actually should be v. My bad. So that's a typo again. So you bind the reactive variable to the input control. And if you are interested in what is typed into the input control or what is the value of the reactive variable, you can always ask it, hey, what is your value? And that's called the view, which is basically the projection, the last value, the current value that the reactive variable has. There's a URL here where you can check this. It will give you the application that I was showing you a minute ago in Try WebSharper. Basically, we can even look at that now. I think we have some time. So there's some user interface artifact here. We have a div, and inside the div, we have another div. So basically, we have this right-hand side. And then we have a reactive variable bound to this control here that I'm highlighting or trying to highlight. So underneath that is an input control that I have bound to a reactive variable. So when I do something like hello world, I'm typing in, what happens is that the output stuff underneath retrieves the projection of that reactive variable, maps it to something else, and then display it reactively. And the way we have accomplished that is in this part of the code. It's very difficult to hold the microphone and show you the code, but that's where we get access to the view. And these guys down, those 8 or 10 lines, so these are mapping that view, the value of what is typed into the text box, into some other kind of value. The first one says view caps, basically capitalizes the text that we entered. The second one, view reverses it. The third one, the third one splits it using spaces, and then gives you how many of those you have, how many occurrences. In other words, how many words do you have in the input. The fourth one basically maps that to a string, and the fifth one says, is that divisible by 2? If yes, then say even, otherwise say odd. So basically you can see I typed hello world, we have the capitalized, the reversed version, we have the word count, and is it even or odd? It says even. And the way we embed all of these is simply here. For each of those views, we create a table, and then each of the rows become TDs and TRs, and then you have this table representation that we see on the right-hand side. So this whole code base is like 100 lines, and we get a reactive user interface that shows you some kind of view mapping. So hopefully, you can kind of see that even the most complicated things can be broken down into reactive, like they can be reactively decomposed in such a manner that they become trivial to write. A shopping cart, an internet bank application, any kind of more complex web application that you can think of is basically a series of interactions between different, typically reactive components. And if you dissect your application into such components, they become really easy to put together. And you can embed them in a sitelet, and you can serve them maybe potentially with a REST service in the backend, and you're done. We can show this basically too. Yesterday in the workshop we had looked at a couple of reactive examples, and one of the examples was this to-do application. But we have such a slow network, I don't know if I can actually show you. Sorry, I said leave. So while this is loading, as you can imagine with 900 people, the network is pretty slow. While this is loading, let me go on and talk about formlets. And from now on, I'm not going to spend too much in the technical details. Hopefully what you will see is the kind of complexity that we can scale up to from here. So we have a reactive foundation, we have a web framework underneath, we have some functional abstractions that we are using. And now let's see where we can take these abstractions. And the first step is formlets. What you see here is what, 5 lines? This basically declaratively defines a form where we input the first name of a user, we input its age, or his or her age, and we even have a client-side validation that makes sure that whatever you enter has to be an integer, otherwise it will say, I need an int, and then we map that component into an int value. And thus, with the star operators in the angular brackets, those two controls are composed together, and now you have a type called formlet, which now supplies a string and an int value for whatever has been typed in. And the control itself, when you render it, looks something like this. Except this is not that control, this is a password dialog for the other example. But basically, it's a very simple thing. You don't have to worry about how things are rendered, because there is a default rendering strategy built into formlets. They come with the presentation layer included. You as a developer, you don't have to output what kind of code you want to see. It gives you a default representation on the user interface, which ultimately ends up being one of its problems. But before I discuss that, let's look at dependent formlets and flowlets. So in this one, we have a computation expression called formlet.do. And basically what you can see here is that instead of using the typical F# let binding, we use a let bang binding, which says the right-hand side, which is of type some kind of a formlet, is rendered, but it has a dependent control following it, which then collects the age. And then once both of those pieces of data are collected from the user, then in this case we return a record that contains both the first name and the age that we inputted. But the way this is inputted, because there could be a potential dependency, is that you only get the first formlet rendered, then the second, and then you get the response. So this is what we call a flowlet, because the typical way of representing this to the user interface would be each page having some kind of like a wizard steps going from the first step to the last. So that's basically a flowlet, and the type system embedding looks like this. And unfortunately, this is not available for C# because it requires computation expressions, and those only exist in F#. But you can kind of see, for example, you can build a user interface which contains, let's say, a Dropbox, and depending on the value that is selected by the user in that Dropbox, the rest of the page could morph accordingly. So this is how you can express dependent, even reactive user interfaces that collect structured data. Because remember, at the end, from this, I'm not getting some string dictionaries that I have to parse the responses out of. I'm actually getting F# values of different types based on how I map each of the inner controls or formlets. Now, let's combine the reactive programming ideas and formlets. So this is then arrives us at reactive formlets, which basically, if you remember from the previous slide how a format looked like, we have something like that here in the middle. But now we have these other lines. The first two lines basically establish two reactive variables, which are then bound to the input controls. So instead of using controls.input and whatever, we're using controls.input var, which is a function that allows binding that input control to a reactive variable. And once you have bound to those reactive variables, at any time during the execution of this form, for example, in the run function, which runs a formlet and displays it to the user, you can always get access to the values that were typed in. And in this case, we're not doing that. We're simply just getting that passed from above. But we could, at any time, even outside of the form, we could access what values have been typed in just simply by reading the reactive variables. So this is a slight but very useful combination of reactive programming and formlets. But in general, like I said, formlets have the problem of not being able to instantiate how I want to render the formlet itself. They always come with this default look and feel, which looks something like this, and many people don't like it, especially if you have to embed it into your applications. You need to be able to change how it's rendered. And to fix that problem, we arrive at the final step, which is basically piglets that are also coupled with reactive programming. And these reactive piglets we simply call WebSharper forms, which look and function exactly the same as formlets, except you have to use piglet when you construct. And now you also get a piglet.render function, which allows you to render this form or piglet in any way that you want. So let me give you an example. So here's a very, so this is just a dependent format. And it demonstrates just nothing else other than what I already had on the slide. Here's a piglet, which basically uses roughly the same code, but it looks different. It looks more different than this one, doesn't it? In fact, it uses Bootstrap to render this, so the markup is Bootstrap based, and the way we can see that is in its render function, which basically are those 5 lines. We make calls to some library, which actually happens to be coming from webshopper.forms.bootstrap, the last open statement that you see on the top of the file. It gives us some very basic abstractions, so we don't have to write the Bootstrap-based markup, which has certain classes that Bootstrap defines. Instead of having to remember all that, we can say, using that library, controls.simple.input with error, and we get an input control with the error showing labeling management capabilities. And then you get something like this, and then you can play with this and say, well, let's log in without specifying anything. Well, then Bootstrap will immediately tell you, hey, this control needs some value, this control needs some value, and we even have an error summary underneath. All of that is basically coming from the show errors and the validation with error primitives from that base. It's a very small library, by the way. webshopper.forms.bootstrap. It's about 100 lines, and you have the full source code in one of the repositories. And then we have this user interface on the right-hand side. So hopefully you get the idea that you can declaratively define what a user interface, what kind of data we expect from the user interface. And you can also couple that with a custom rendering technique or way of rendering. And therefore you can, if you really are after some of the more heavy and hardcore abstractions here, you could even bundle certain piglets for reuse. Let me give you an example. So let's say we had an application that is available as a web application and as a mobile application. This is becoming pretty typical, like your favorite Gmail client on your phone. You probably have, if you have Android, you probably are using the Gmail client to read your inbox. That's a mobile application, but there's also gmail.com for the web application. And potentially there could be, I don't know, maybe somebody at some point will invent a set-top box that you can put on your TV, and then you have some other means of interacting with your Gmail inbox. So those are different incarnations of the same application. In other words, they have different user interfaces, but ultimately they are able to basically typically expose the same kind of functionalities to you as a user. So what you can do here is you can define piglets to represent that abstract interface, and you can render them based on whatever condition. Like, am I running on a mobile phone? Well, here's my mobile engine, my mobile user interface for that particular piglet. And the piglet itself, of course, needs to be multi-shaped. It needs to have, for each of the pages, each of the different parts of the functionality, provide the right user interface. So it will become fairly complex. I'm not saying that this is trivial, but it allows you to abstract away the rest of the application. So everything that is not the user interface could be factored out and saved effectively into the type system into a piglet value. All right. So there are a couple other things that you can do, and this now becomes in line with, for example, writing mobile applications, single-page applications, basically applications where you have a bundled JavaScript and HTML-driven core in which certain models, certain views, certain pages pop in. So these single-page applications typically end up being in one single HTML file, which inside of itself will emulate different pages to the user. So if you have some mobile application where you swipe left and right, each of the pages you see is only a fragment of the document that exists in that one single page application. And oftentimes you need some kind of a nicer way to be able to switch between these pages. And there's a small example I put together for reactive sitelets. So basically being able to, in the client side, emulate having different pages and doing client-side routing within your application. And it's nothing fancy, don't expect anything too big. It looks something like this. So we have an About page, which has a link to the home page, and if I click the link, it goes to the home page, which has a link to the About page. So it's not very exciting. But the good thing about this is that that application has a single page. And both of these pages are nested inside. And we have this very nice ability to, first of all, address the other page in a type-safe manner that I'll show you in the code, and go to that page as well. And the whole code base is, again, probably something like 50 lines. And so here we go. We have a home page and we have an About page. And simply, we have a reactive variable keeping track of which page we are on. And depending on whether that reactive variable changes, we simply have a user interface, like a jQuery operation that switches from one DOM element to the other. This is what's being performed here in the bottom. It says if the reactive variable says we are on the home page, we should switch to the home page, which basically some client-side routing and everything driven approach, it's able to give that DOM node back to us. The whole thing about the route map is that if we saw the URL bar, like if this was actually executed in the browser as a separate window, not in an iframe, you would actually see the URL changing when you go from one page to another. And so that's like some hashtag-based client-side URLs, so that even the browser sees this as new pages going from one to another. So if you are bundling this application up into a mobile or looking at the application in a web browser, the back button will be able to track each of your movements. Like if you went between the two pages 5 times, you can go back and forth 10 times backwards, which is nice. So in other words, it keeps the history of your page changes, and it also establishes full client-side routing, which is, as I realize, a fairly advanced topic at this point, but it shows you that you can also implement these if you're basically writing mobile applications, for example, with WebSharper. All right, I think I'm pretty much running out of the things to discuss. So we went through sitelets to represent microservices, in client-server applications, the server side, so basically anything on the server side. And then we went through several abstractions, from formlets to piglets, and finally reactive piglets, about how you can develop and how you can abstract user interfaces, client-side user interfaces, within the same application. And using WebSharper, you can put these two together, and in the same single code base, even in a single file, you can write and realize and implement applications that have client-side and server-side. So I wanted to show a couple examples here, but probably because of the web not cooperating, this is going to be a bit difficult. But we have basically probably about 200 different snippets, ranging from using different kinds of JavaScript libraries. We have a reactive to-do application. We have some visualizations. You can use the filter down here. So if you wanted to do let's say visualizations, I could turn on certain visualization libraries, high charts, or anything else. Let's look at some D3. Maybe we have some funky one. So what's D3 intro? As I said, yeah, I mean, that's just some silly visualization by somebody. So we have a few dozen users who are actively writing these snippets, including ourselves. So this is always a good page to go and just try something dynamically if you want. And let me just basically open up Snooker, and we can look at that while I'm closing the talk. And before I do that, I wanted to bring your attention to a couple other things. So I said that basically one of the ways of using WebSharper is in Visual Studio, Xamarin Studio, and different IDE integrations like in Atom and so on. You can even do it from the command line with a couple basic tools. So it's very, very easy to get started. Another way to basically get started is using Cloud Sharper, which is an online IDE that I demoed last year, so I'm not going to do it. You can view the video from last year. It's basically an online IDE where you edit and you can create and edit and even deploy web applications using Web Sharper and F Sharp. So this is what it looks like. You have a project, just like in Visual Studio. You can open files and edit them. You can build them, and you can deploy them, and you can see them running in the same shell. The reason I'm bringing this up, because we have an upcoming version of this under a different name, which basically is able to do the same kind of project management. It can give you the ability to edit different types of projects and switch out from one project into another. But it also gives you the ability to put your applications and deploy your applications and even deploy the service required to run all this into any of the cloud providers. So here's one setting up, it's a dialog box that basically helps you setting up a new host. And in this case, it can deploy the host using just a single button. And it triggers then a dialog with Azure, and you log into your Azure account, and it creates the service inside your Azure account. And therefore, you can then, if you see here, I have F Sharper and my Azure host and my laptop, 3 hosts configured in this particular installment. I have the ability to actually add the new host. What I can transfer applications from my laptop to the cloud. I can take a cloud application and shift it down to my laptop. I can edit them from any one of those places using this online ID. And I can set up other hosts. I can create projects, and I then have the editing capabilities that we saw in Cloud Sharper. So basically, this is automating the different places where you could be writing applications and the different ways and the different places they could be deploying applications into. So this is automating. It's basically like development as a service in an integrated cloud-based offering. And so I just wanted to mention that this application as well has also been written using Web Sharper. And that's pretty much all. I'm not sure how I'm doing with time. I'm usually always running late. So I would like to take some questions if you have any. Anybody? Yes? Okay, so there was a question here about what are the benefits, if I understood correctly, of using Web Sharper and or F Sharp, right? Okay, so first of all, let me take that as a question about Web Sharper, because I think the benefits of using F Sharp versus something else is an objective question. I have gone over that yesterday in the workshop. So the benefits of using Web Sharper as opposed to some other web development technology. And before I even answer, let me make that clear that these Web Sharper applications are ASP.NET compliant, so you can plug them into IIS. You can plug them into any OWIN compliant container, Katana, etc., etc. You can self-host them, which means you can generate an executable that serves the application itself and nothing else. And basically, within an ASP.NET shell, you can put any other ASP.NET application next to your sitelets. So you can basically take an existing legacy ASP.NET application and you can start writing additional functionality represented as a sitelet in F Sharp. So this is all basic. So that's like a prerequisite here. So next to those, what would be the main advantage of using Web Sharper? I would say the number one advantage is the ability to write the server-side and the client-side code in F Sharp in the same language, and now also with Web Sharper 4 in C Sharp. So this means no more JavaScript, no more loosely or semi-typed scripting. Everything is strongly typed in the type system. When you compile your application, you get red squigglies everywhere where you made a semantic mistake, even between the client side and the server side communication, or in your logic on the client side or the server side. So everything is cross-checked. Because you have code completion and other capabilities, you actually develop code faster. And one of the other main primary reasons is that once everything can be done in C Sharp or F Sharp, I don't have to get a backend developer, a client-side developer, a database developer. all I need is a single role called F# or C# developer who can now take care of all of those chores or details. So this simplifies the structures of development projects. It, in my experience or in our experience, it dramatically shortens the life cycle of developing a project. So something like 6 months with 10 people is now 4 months with 3 people. So this is like resource-wise, speed-wise, everything-wise, faster and better. And then maintenance-wise, because you have eventually a much smaller code base, roughly on the scale of 5 times, 7 times less than using the mixed and traditional approaches, those applications then also become much easier to maintain. So overall, it's a win-win situation, and it's always just gaining and gaining. All right, any other question? Yes? Okay, so let me repeat that. So the question was, what was the biggest web shopper application that we developed, and what were the main problems, issues that we encountered? So we have 30 plus number of enterprise applications that we developed for different customers. These were typically anywhere between 2 months to 6-8 months projects. And the largest application, and besides that, of course, as you saw, we have Cloud Sharper, we have this new upcoming version of Cloud Sharper, we have a couple community sites, fish.net being one, and we have quite a few other larger websites that we have developed using Web Sharper. I would think the largest, now that I'm trying to recall which one would be the largest, I think the largest is somewhere around 60,000 to 75,000 lines of code, pure F# code, probably of the equivalent of about 500,000 lines of C# and JavaScript. I don't count the JavaScript actually. The JavaScript would be megabytes and megabytes generated at the end. And the biggest challenges that we encountered were basically, I think number one challenge was taming some of the JavaScript libraries that we used. So you can use any JavaScript library in your F# or Web Sharper projects. Anything, even your own JavaScript code base. You can bring that code base in and you can address it and use it from F# or C#. And you cannot treat it as an external dependency. The biggest challenge, I think, the single biggest challenge was getting the different JavaScript libraries into the type-safe discipline of C# or F#. In other words, we had to type them. We used TypeScript declarations as one means of importing type signatures, but they typically end up being buggy and they're not all-inclusive, so many times we had to write them manually by ourselves. We have an embedded DSL syntax for expressing APIs, JavaScript APIs, for Web Sharper applications. And the biggest thing was matching that with the JavaScript code base, like figuring out what is the API of JavaScript code bases. This is not a problem with small JavaScript libraries, but when you have like large JavaScript frameworks that are thousands and thousands of types and classes and members, that becomes a pretty big source of problems. So luckily we have over 60 of these extensions, we call these extensions for Web Sharper, for small libraries like jQuery, ranging all the way to massive, huge libraries like SenchoTouch, XJS, Kendo UI. All of these are mapped into Web Sharper extensions. So that would be the single biggest challenge, I think. But now, for the most part, we have these under control. All right, I think, okay, maybe we can take this one more question and then.
Hello. Is it possible to write unit tests for the pages written in
Unit tests?
Yes.
Yes. Good question. So the question is it possible to write unit tests? So when you look into the Web Sharper repository, you can see that there is a web testing framework included. It's called websharper.testing, included in the repo, which basically means every time you write either C# or F# JavaScript-based applications, you can have this testing framework test not the C# and the F# semantics, but whatever would be translated to JavaScript and testing it on the client side. So there's a full testing framework that allows you to double test and double check your own F#, C# code in JavaScript. And that's seamlessly integrated with Web Sharper. The other things we do is naturally people make mistakes sometimes, either by the bindings that they bring in from JavaScript or sometimes in their own code. What we have is we have source mapping available in F# and soon also in C#. So when you debug the applications that you wrote with WebSharper, you're not debugging JavaScript code anymore. You're debugging the original code that the developer wrote. So in your browser, you can, using source maps, you can see and jump around the different source code lines in F# and C#. So that also speeds up development and debugging in case you need to do some debugging. So I would call that pretty advanced and pretty sophisticated for the time being, but there's always more stuff coming and more abstractions. And indeed, the key idea is that we want to eliminate the need to ever have to look at JavaScript. We want to treat that as a low-level language that is maybe participating in the execution of projects, but never in your development and never in your debugging and never in your deployment. All right, I think my time is up, so thank you very much for coming. I appreciate it. Thanks again.